Hi, I'm Dave Cocking from DesignBuilder. This video replicates what I would have done live at the conference, focusing on showing you DesignBuilder's workflow in real time, so you can see for yourself why DesignBuilder is different. In well under 30 minutes, I will build a model and then run load calculations, an ASHRAE 90.1 Appendix G PRM simulation, a LEED daylighting simulation, and even a quick CFD simulation. No other software can do what DesignBuilder can do in that time, demonstrating why DesignBuilder deserves its reputation as the most high productivity building performance simulation software available. So what is DesignBuilder? It's a fully integrated simulation toolbox, a GUI that enables you to quickly create models, run simulations using the best open source simulation engines available, and then generate impressive outputs. You build one model, then run all these analyses from it. Use EnergyPlus to run load calculations and energy and comfort simulations, generating outputs for design and compliance with LEED, etc. Our powerful industry-leading tools include scripting, optimization, uncertainty and sensitivity analysis, and cost. From that core model, you can also run daylighting simulations using the Radiance engine and internal and external CFD analyses. I'll point to some resources on our website at the end where you can find out more. Enough PowerPoint, now for the software. I'll first create a simple early stage model, then add detail to create a proposed building model before auto-generating a baseline building and running a range of simulations. I'm approaching it like this to show you that when you use DesignBuilder, you don't have to ditch your early stage model and start again in different software. You could create the model geometry by importing CAD plans and facade drawings in various formats, or import a 3D model from a BIM tool or from a GBXML file. I'll create the geometry freehand here. I'll start by creating a U-shaped block 90 feet by 90 feet. Notice how the mouse cursor snaps to the X and Y axes in the horizontal plane. I'll then add a monopitch roof with an apex of 16 feet to the east facade and snap so that it's level with the back wall. And I'll now use the mirror tool to reflect that block on the opposite side of the ground floor block. The external geometry often changes as the project evolves after the initial model is built. No problem. The geometry you imported or created yourself can easily be updated in DesignBuilder. I'll modify this ground floor block to create a symmetrical H shape, and then I'll increase the core zone height by 2 feet. You can also modify smaller parts of surfaces. Here I'll create an inset entrance to this core zone to provide shelter and shading for glazed doors. The internal layout is defined in DesignBuilder as you would in a real building by adding partitions to separate spaces. I'll create a core zone on the ground floor using the partition tool. If the internal layout changes, again, no problem. You can easily move or redesign internal layouts as the design evolves. I'll now rename this core zone my reception zone. So now let's take a look at how DesignBuilder's intuitive interface and high productivity data management mechanisms make modelling faster and easier while setting up a simple proposed building. Going to the site level, When I created this new model, I selected the ASHRAE 90.1 option with Chicago set as the location. DesignBuilder's library includes data for over 5,500 ASHRAE climate locations globally. The closest hourly weather file is set automatically according to the location. You can select other weather files from the DesignBuilder weather library or add and use your own file. And the heating and cooling load calculation details are set according to the location too. The workflow in DesignBuilder is logical and intuitive. After creating the geometry, you simply work from left to right through the data input tabs. This panel on the right is a context-sensitive help function. As you watch the video, notice how this changes to provide information and links relevant to what you're doing in the model at any particular time. I'll start here in the Activity tab at building level. This is where you set internal gains due to occupancy and equipment. All data in the tab can be set very quickly from a single template here at the top of the tab. Templates are used to bulk load lots of information with one model input. In the Activity tab, that data includes the schedules, heating and cooling set points, ventilation rates, lighting illuminance levels, etc. DesignBuilder includes extensive pre-populated libraries for typical activities, including ASHRAE 90.1. This was created as an ASHRAE 90.1 model, so the activity data here is set according to the relevant ASHRAE standards. Data set in the tab by the template is not locked down. It can be edited as required, or you can create and set your own templates with the data you commonly use for particular clients. DesignBuilder uses a data hierarchy and inheritance mechanism to speed up modelling. As you create the geometry, DesignBuilder organises the model into a hierarchical structure of buildings, blocks, zones and surfaces, which enables you to quickly navigate the model and input data. You then set the most common data at building level, and it is inherited by the blocks and zones below. For example, if this was a 100-zone office building, I'd set the relevant office activity at building level and would then only need to change the template in 10 or 20 of non-office zones, such as circulation areas and storerooms. You can set up an early stage model in about 2 minutes using templates from the DesignBuilder library. Less data to input minimises modelling time, but also significantly reduces the risk of data input errors. So in DesignBuilder, you only need to change data when it is different to that set at the level above. I'll now go to the reception zone and change the activity to reception. This changes all relevant data below, such as the ASHRAE 90.1 lighting category. The Construction tab is where you define the opaque building fabric. The same template principle applies to constructions, openings, lighting and HVAC data, with the most common data being set by the template at building level. Use a template from DesignBuilder's library or one you create, perhaps for example to comply with regional code requirements or for clients using a set construction specification. I'll load the best practice construction template. See how this has changed all the constructions below. I could set a different template for any building, block, zone or surface in the model, and also change individual settings with the tab at different levels. Let's take a look at DesignBuilder's extensive pre-populated data library, which contains templates with all common construction and materials options. Here's the library of typical external wall constructions. I'll copy and edit this external wall construction so you can see the layers that make up the wall. I'll name it my DB wall. Layers can be added, removed or edited. Here I'll change the insulation type. Note the extensive library of insulation options, but you can also add your own materials from manufacturer data. I'll select standard EPS material and change the thickness to 5 inches. There's also an option here to specify a U value, which will automatically set the insulation thickness accordingly. You can also set other data, including specifying a cost, which can be calculated from the sum of the material layer costs or input manually. I'll save this new DB wall construction and set it at building level so it's used by all the walls. There is significant intelligence built into DesignBuilder that automates otherwise mundane tasks like assigning adjacencies to internal and external constructions. Based on the geometry you draw, DesignBuilder applies the correct adjacency conditions to the roof, external walls, ground, and internal floors and partitions. You can easily override the automatic adjacency settings, here for example by quickly adding a ground block to represent sloping ground levels around your building. At zone level, you can see how DesignBuilder then automatically applied the below grade wall construction to the parts of the wall in contact with the ground. The Openings tab is where we define the glazing properties. I'll set the best practice template at building level. Opening the best practice glazing type, you can see there's an extensive library of pre-configured glazing types available in DesignBuilder. And looking at the layers in that glazing, you can see that the full international glazing database of panes is also available to select. The facade dimensions options here are used to quickly make bulk changes at early design stages or where a common window to wall ratio percentage is used. The default window to wall ratio here is 40%. This is why new blocks already contain glazing. I'll go to the ground floor block and set the window to wall ratio to 60%. So that I can visually compare the proposed and baseline buildings later. You can also draw openings onto surfaces and copy them to other parts of the building. I'll place the upper story east block windows and then clone the new window at surface level. And finally, I'll copy both windows to add 2 roof lights to the east roof. If I had drawing plans, I could attach the glazing to specific points on a surface with the plan overlaid, or just draw them onto the plan. DesignBuilder provides useful tools to customize your model quickly. Using this Load Data from Template tool, you can quickly set up model data in 2 ways. One common use is to select all the data for a zone with common data inputs. For example, all WC zones have the same activity template and will often have similar glazing, lighting and HVAC. So relevant options for those could be specified here and then quickly applied to all relevant restrooms in your model. This tool can also be used to add particular glazing types or shading on selecting facades, using the selection filters to quickly apply options like blinds, overhangs and louvers. I'll select this double glazing with 1 meter overhang template. Using the selection filter to apply that template to all external openings plus or minus 30 degrees of south. I'll also apply a slope range so the data is only applied to walls, not to the roof. Going back to the model, you might be able to see the shading on the south windows. I'll use the visualization tools to show the shading more clearly. This Model Data tab is where you can visualize construction and glazing assignments for visual QA checking. If I look at the ground floor block, you can see where the below grade wall was applied to the northeast corner of that ground floor. You can change the colours in the constructions and glazing properties too. At building level, in the rendered view tab, you can see the shading more clearly, and I'll apply shadowing. Back now to the lighting tab, which is where you specify lighting gains and any daylight control. I'll switch on daylight control, and note also the ASHRAE 90.1 lighting options here. A new DesignBuilder model starts with the simplest HVAC and natural ventilation options for fast early stage modelling. You can then add detail as required. Simple HVAC uses the EnergyPlus ideal loads method, which is easy to set up and fast to run. You just choose the relevant template and configure the simple options. DesignBuilder includes a number of pre-configured templates covering most common system types. These are great for early stage modelling. I'll choose the VRF air-cooled with heat recovery and DOAS template, and you can then configure this to match your own system by switching mechanical ventilation, heating, cooling, domestic hot water and natural ventilation on or off, and setting the primary operating data such as system efficiencies and fuel types. Note that this model is set up as a detailed HVAC model automatically because it's an ASHRAE 90.1 model. I'll also go to the Economics tab and I'll add tariff analysis. So you can see the cost comparison for the 90.1 Appendix G performance rating method results later. You can also set up cost data here for construction cost, life cycle cost and life cycle analysis calculations. So you've now seen me set up this model and make changes as I've gone along. What I've covered could easily represent an early stage building. So we could start to run calculations at this stage to check energy and comfort performance to help inform the design. To reinforce that, I'll run heating and cooling load calculations now before I set up a more detailed HVAC system. Starting with heating design, this is a steady state calculation for determining heating plant loads using winter design data. I'll run it using the default options. The temperatures and heat balance are shown graphically, and results can also be viewed in the table below. This is a very quick calculation and it immediately illustrates that fabric improvements in this particular example should first focus on improving the glazing and the ventilation heat recovery. You can also view summary sizing data to confirm the design capacity required to meet the heating loads in each zone. Now on to cooling design, which runs a dynamic calculation for the design day in selected months. It is used for sizing cooling systems using summer design conditions. I'll select the June to September period to identify the month with the highest cooling load. It's a dynamic calculation, but it runs quickly. And it provides useful design data like the half-hourly heat balance and cooling system load graphs. Display data for a specific month or peak month, and in this case it confirms that July is the worst case for this building. You can also view the data in tabulated form if required. You can choose to view the design capacities for either coincident or non-coincident loads. I'll now return to the software and discuss more detailed design stage modelling options. Detailed HVAC and EnergyPlus airflow network options are available for detailed modelling stages, for LEED compliance, etc. Natural ventilation modelling with the EnergyPlus airflow network is orders of magnitude faster and easier in DesignBuilder. I know a few modelling experts who really do squirm at the thought of natural ventilation modelling after trying this using the IDF editor and similar tools. So if you've ever been put off modelling it in EnergyPlus, you should try natural ventilation modelling in DesignBuilder. I guarantee you will be pleasantly surprised. I have limited time, so I'll focus now on introducing you to detailed HVAC. You start by selecting the HVAC system. You can build the system yourself by adding and connecting individual components, or you can use templates of pre-constructed common system types to give you a quick start, and that's what I'll do here. Template systems are still fully configurable, and components can be added, deleted, or edited as required. Here you can see the range of templates available, with these ASHRAE 90.1 templates being used by DesignBuilder when you create the baseline building HVAC system. There is a large selection of common system types, including some fairly complex systems like this ground source heat pump with heated floors and chilled beams. But for this small building, I'll choose the same VRF with heat recovery and DIAS template as before. I'll use this as my primary HVAC system and apply it to all zones. Once the template is loaded, you could add more templates to model different system types in different parts of a bigger building, or add and remove components like chillers and coils and configure the data for the components you have included. Every HVAC system component is editable, such as the main VRF heating and cooling system outdoor unit here. There are a range of manufacturer system templates already included in the DesignBuilder library, including the latest Toshiba Carrier VRF systems. All of the component data is editable, including the performance curves. DesignBuilder provides curve generation tools to help you set these systems up. If you need help setting up a particular aspect, you can use this help button to access information related to this particular dialog from our fully integrated help system. Let's assume our HVAC system is now configured, so it's time to QA check the model before running simulations that will generate your final results. In addition to the geometry and data tab displays, you can QA check your model using DesignBuilder's Grid, View and Edit tool here. I'll select the Edit option for the two activity data layouts. You can very quickly see what data has been assigned where, and any data that has been changed in the model is coloured red. This helps you to easily see whether input mistakes have been made. You can edit the model data using this tool directly. Here I'll edit the heating set point for all zones. You can also export data to CSV, edit or add data from other models or calculation sources to the CSV file, and then import it back in. Now I've QA checked and updated the model, I'll use DesignBuilder's baseline building generation wizard to generate the baseline building automatically using the proposed building data. The wizard dialogues are summaries of the data inputs used to generate the baseline building. The baseline building appears next to the proposed building, enabling quick comparison. You can immediately see that the baseline building glazing and shading have been changed to meet ASHRAE 90.1 requirements. Model data in the tabs has also been changed. See, the constructions and glazing templates have been replaced with ASHRAE climate zone data, for example. Before running the ASHRAE 90.1 calculation, I will generate the baseline building HVAC system using that wizard. You can change data such as the selected system type if required. I'll apply the recommended system to all 5 zones. I'll now run the proposed building simulation using DesignBuilder's calculation options that are pre-configured for ASHRAE 90.1. Before running this simulation, you should of course normally run QA simulations to check the correct operation of systems, etc. Next, I'll run the baseline building calculation to generate the comparative results. ASHRAE 90.1 results can be shown as an energy comparison, as here, and as a cost comparison too. You can also generate a LEED V4 minimum energy performance calculator spreadsheet. The spreadsheet includes the results from these ASHRAE 90.1 calculations, speeding up the LEED submittal process. This takes a couple of minutes to generate, so I'll skip the generation time and quickly show you the spreadsheet. I'll now briefly introduce DesignBuilder's daylighting tools. I'll run a quick LEED V4 option 2 illuminance-based calculation using default settings at the standard resolution. DesignBuilder already includes data for glazing light transmission and surface reflectances, etc. You can check and adjust those as you need to. You can customize the display, including displaying grid cell values and customizable color palettes, for example. The current view is for 9 AM with the sun to the east, and now at 3 PM with the sun from the west. I can also view the data in grid form or as a LEED V4 option 2 report as here. I'll look at the daylight distribution maps for the 2 upper story blocks. You can see the impact of the roof lights on block 2's results. You can also run construction cost, life cycle cost and life cycle analysis calculations using the same model data. I'll run a quick construction cost calculation and generate a Uniformat 2 report. This report uses the surface areas and constructions and glazing data, plus the cost information you specify as calculation inputs. One of DesignBuilder's great strengths is its fully integrated approach, enabling you to set up one model and seamlessly run a variety of different analyses from it. So I'll quickly run a CFD calculation for block 2 to reinforce the point. DesignBuilder includes default boundary conditions which you can set up in the CFD Model Data tab. But because DesignBuilder is fully integrated, you can also import EnergyPlus simulation results to generate more accurate CFD boundary conditions. I'll pause the calculation before it converges and take a look at some preliminary results. As you can see, the early results already show that the cooler windows are starting to influence airflow patterns due to downdrafts. I'll finish by pointing out some useful resources on DesignBuilder's website. There are lots of free online video tutorials here, and also lots of free webinars on hot topics like optimizing HVAC system design via modeling. All our classroom training is available in a convenient and cost-effective interactive on-demand online training format. And on our homepage you can access a free 30-day no-commitment evaluation license here. Thanks for listening. We hope you enjoy the conference.